So when it comes to our trig functions, some important things happen specifically when we land along the axes. So if, for example, we're looking at what happens for an angle that happens at a multiple of pi, for that is an angle landing along the y-axis, something like theta equals pi, or theta equals 2 pi or 3 pi or 4 pi, however many multiples of pi we want to look at. What's going to end up happening, if we think about the point that we land along on that angle, somewhere along that ray we might consider to make the radius of a circle, P is going to have form plus or minus x, 0. Our point is going to be entirely determined by the x value. That's going to tell us what the radius is going to be in that case. So, if we have P of form x, 0, well, looking at our options here, some important things are going to happen. We're going to have that any value for sine of theta, because sine has a y on top and y is always 0, is going to be 0, and so will tangent. Meanwhile, for cosine, because we have an x on top over an r, we'll have something of form plus or minus 1, depending on whether we're on the positive x or negative x. And that same thing is going to happen for secant, because the radius is just the x value. Now the radius is always positive, but the x value could be negative, which is why we have to be sure that we know it's plus or minus. And then in the cases where we have y's in the denominator, cosecant and cotangent, we will end up with our function being undefined. Because at those points, we need something in the denominator for r, but unfortunately, we don't actually have anything. And as a result, function's undefined. Similarly, if we talk about angles that land us along the y-axis, so things like pi over 2 or 3 pi over 2 or 5 pi or 7 pi or 9 pi over 2, things of that form, things of that nature, our point will instead be of form 0. Along the y-axis means you don't have any x values, and plus or minus y. And as a result, anything with an x in the numerator is now going to be 0. So that means we will have that cosine as well as cotangent, in this case, are both going to be 0, while terms that have y's in them, terms that are defined around y's and r's, that is sine and cosecant, will both have form plus or minus 1. I don't know why I'm throwing these parentheses in there for this one, but not that one. It doesn't actually make a difference. But anyway, for our last couple of cases, we're looking at ones that have an x in the denominator, and because that would mean having a 0 in the denominator, tangent and secant would be undefined. There's nothing for them to do. There's nowhere for them to go. They do not exist for these types of graphs. And we can use this to get some interesting values for trig functions, some values that might be a little bit clunkier to get, provided we can work around these patterns, which we're going to see with our next example. So for this example, we want to find the exact value of tangent of 13 pi over 7 times sine of 3 pi plus cotangent of 13 pi over 4 times cosine of 3 pi, which is a lot. No two ways around it. That's not the very friendliest of equations, or expressions, excuse me. Especially that value 13 pi over 7. We don't really do much with values of pi divided by 7. You may see in a bit with, I can't remember if it's Calc 1 or Calc 2, where you do some approximations, that there's a thing called the small angle approximation that can work with pi over 7 in particular. But in terms of exact values, it's not a nice one. It's one we like to avoid. However, we're going to see that if we work in terms of some periodic properties, we can actually get around that. So if we take that sine of 3 pi, we'll see that sine of 3 pi is sine of pi plus 2 pi. And if we recall from back a couple sections ago, this was 2 sections ago, we had that the period of sine is 2 pi. So if you add 2 pi to anything inside of a sine function, it essentially doesn't do anything. It just repeats the value a little bit further to the right. And as a result, that's just sine of pi, which is 0. Similarly, for cosine of 3 pi, we can write that as cosine of pi plus 2 pi. Period of cosine is also 2 pi. And accordingly, we get that that's just cosine of pi, or negative 1, because it comes around to the other side on that axis. Negative side, x value, negative 1. Meanwhile, for cotangent of 13 pi over 4, doesn't look nice, but we can recognize that 13 pi over 4 is 12 plus 1 pi over 4. And we can pull out that 12 over 4 with those pi's on there and get that this would just be pi over 4 plus 3 pi inside of cotangent. And since the period of cotangent was just a single value of pi, that is really just cotangent of pi over 4, which we saw in the previous section. It's actually just 1. So as a result, we can take that horrible looking thing and pull it down to some much nicer parts. Tangent of 13 pi over 7 times 0 plus negative 1 times 1, or negative 1. And the last thing we're going to see from this section is a very important acronym for how we can determine the signs of our trig functions.